Okay, in this video, I'm going to spend a little bit of time looking into more detail on energy transfers. Calculating energy by itself is really basic. It's the energy transfers that we're more interested in. So, um, one of the first things I want to kind of show you then, and this is probably new to you, is this idea of work. So, here's an example. Consider a spring that gets stretched. So, before it's stretched, it has some length L, and we can say that it has a um, spring force or spring energy of 1/2 kl squared. And then sometime later it has a larger length, it's L plus X, and we can see that that spring energy is going to be greater than the previous one. Okay, now let's suppose we're going to study the system with the only thing in the system is the spring. So at one point we had ES1, sometime later we have ES2 because it has a larger stretch, so it has more energy. And we said earlier that energy in a system has to stay constant. So the question is, well, how is that possible? If this ES1 is clearly smaller than ES2, how does that happen? And the answer to that question is this word work. Um, so if we started with something like, let's just say 5 joules of energy and later on it's 10 joules, how does it get like that? It's because someone did some work to the system. Someone put 5 joules of energy into the system so that it would be stretched. So that's the idea of work. Work is transfer energy in and out of storage systems from an external force. So in this case, it would be a hand that's not in the system. It's a hand that's transferring energy into the system. Okay, so that's work. The other thing that I want to go through is how to track energy transfers. And I really like to use what I call bar charts or LOL charts because this chart looks like LOL. And these charts look like this. We have some starting position or some point in time where we can list all the energies present. We make sure we're really clear in saying what objects are in the system. And then we analyze the energy in the system at some time later. So position A and B, we can also think of them as snapshots in time. This bar chart, we'll make bars on it. It's qualitative. We're not saying something's 2 joules or 18.5 joules. We're just looking at relative sizes or things going bigger or smaller, stuff like that. And once we're finished with our chart, we can get an equation from it. Like let's suppose thinking back to a previous video where we had a ball that was held above the earth. Maybe it has 4 bars of energy. And then later it drops down the ground and it has a whole bunch of speed. So it has 4 bars of kinetic energy. And we can use a bar chart to say EG equals EK. So this equation comes right from our bar chart. And as we do examples, you'll see what I mean.